All right. I just got the thumbs up from Christy, so we'll begin. And my name is Neil Edson. I'm president of the Tennessee Urban Forestry Council, and I want to welcome, uh, for those in the Central Time Zone, good morning. And for those in the Eastern Time Zone, during your lunch break, good afternoon. But to welcome you to this third in a series of webinars put on by the Tennessee Urban Forestry Council and the UT Residential and Community Forestry Work Group. Uh, it's our intent to do this on a monthly basis and to provide meaningful speakers and topics that help you do a better job of managing your urban forest and enjoying the benefits of our community trees. Um, Today's speaker is going to be talking about stand dynamics in the Old Forest State Natural Area. He's Eric Bridges, and he comes highly recommended. Many of you have heard him before. And with no further ado, let me turn it over to Dr. Jean-Philippe, who's going to introduce our speaker.
Good morning and good afternoon, all. I would like to introduce you all to Mr. Eric Bridges. He is currently the operations director for the Overton Park Conservancy in Memphis, Tennessee. Eric earned his BS in forestry from Colorado State and his MS in forestry from Mississippi State. He's currently a PhD student in the Department of Forestry at Mississippi State. His research focus area is urban forest dynamics. Eric is a certified forester and a ISA certified arborist. He has worked as a forester for 29 years, including work with the National Resource Director at the City of Lakeland, Tennessee, and also Colorado State Forest Service. He is an active member of the Tennessee Urban Forestry Council, and a founding member of the Memphis Tree Board. We welcome Mr. Bridges. Thank you.
Okay, Eric, you can start sharing whenever you're ready.
Okay, can everyone hear me? Christy, how's my sound?
You're a little quiet, but also we're not seeing your full screen. We're seeing your notes.
Okay, thank you.
In your next slide.
Got it. All right, how about now?
Perfect, thank you.
Okay, thank you all. Okay, well, I'll try to project. I know a lot of you, and you know a lot about me, unfortunately. But I want to thank everyone for coming today. It's my pleasure to be here and to talk about the work we're doing in the Old Forest State Natural Area. So on the slide, of course, I'm listed as Lee because that's the way they make us do it at Mississippi State. But together with my major professor, Dr. Grado, we have some interesting things to share, I think. So I hope this will be useful to you all. Before we get started, though, I want to acknowledge the technicians that we've worked with. And there have been many over the years, but in the summer of 2019, these two were the primary ones. This is Bono Paladice in the back there, and Ali Swanson taking the picture. And I believe they texted me this photo when I was on vacation one day just to let me know that they were out there sweating, getting the field work done. This is part of our partnership with academic institutions in Shelby County. Bono is a Christian Brothers University undergraduate, and Ali was a Rhodes College student at the time. So we built these internships over the years to get this kind of research done. And then they clean up nicely, and we take them to conferences. And we added Ali Swanson there. She wasn't, Shannon Kane, she wasn't in the field that summer. But this is us at the Society of American Foresters in 2019 presenting some of our research. Okay, so let's get into it. I have a really simple outline for today. Just three things. I want to talk to you about the site where I work, the research we're doing at that site, and some of the management activities that we're doing as well. So the site itself, many of you know, is the Old Forest State Natural Area. It's a 126-acre forest located inside the boundaries of Overton Park in Memphis. Overton Park is about 342 acres. And so the forest is the biggest part of Overton Park. It's located in Lucy Braun's Western Mesophytic Forest region. And also Dr. Hodges called this the Brown Loam Bluffs. It's the area that sits up on the Chickasaw Bluffs in West Tennessee. So our species composition is mixed mesophytic, which means it's, we call it a gumbo. It's just a combination of everything. Upland species, bottomland species, shade tolerance, light demanding, early successional, late successional. It's really fun to work in a mix like that. And our forest seems to have reset itself somewhere around 1835. So the trees we've been coring, mostly the overstory trees, I should say, date back to about that time period, plus or minus a couple of years. And as you can imagine, in an urban forest, we have an abundance of invasives. And then the Overton Park Conservancy has been managing the site since 2012. Prior to that, we really haven't, it doesn't appear that we had any organized management. Certainly groups were doing work in the forest, but not under some cohesive management plan. So some of the key features of the site itself, there are several compelling features for which it's known. First, the vines. There are some extremely large grapevines and other vines. We have apparently around 12 species of vines in the forest. And there's Wes Hopper, everyone knows Wes, leaning on a massive grapevine. It's also known for spring ephemerals. So, you know, the phlox can bloom very heavy. And then in the upper right, there's a picture of the celandine poppy. So just these masses of spring blooms. And they just come out for a few weeks before the leaf out. So you have a very narrow window where you can get pollinated. But it's also known for giant trees. And so that's Allie, kind of a blurry photo, but just standing next to a very common overstory tree. That tree, I think we measured at about 145 feet tall, but we have specimens that reach 165 feet tall and 6 feet in diameter, not uncommon. So that's interesting, but is it old growth? Would you call it old growth? Well, the term old growth can be pretty value laden, so we often shy away from it in forestry, but there are a lot of definitions, and if you look through them, there's some common themes for what makes old growth. And so if we walk through the 5 most common themes, I think the old forest has most of them. So large old trees for their species. Large is subjective, right? It depends on the species, but we definitely have large old trees that you saw. Snags, you need to have standing dead trees to be an old growth forest. And there you see the pileated woodpecker in the old forest carving out its home. We have lots of snags. Down woody debris is a characteristic you need to have. And so you see the picture on the right with a large down log. We have lots of down woody debris. Something called pit and mound topography is important. I didn't take a picture of it, but where old trees fall and the root mass becomes a mound as it decomposes, and the pit is where the roots used to be. And if you walk through the old forest, you'll see an abundance of pit and mound topography. And then the 5th common characteristic for old growth definitions is a lack of human disturbance. That's one, well, I guess if I could, I'd insert a buzzer sound here. Like, we can't make that one. It's an urban forest, but I think I would argue that almost every forest has some human disturbance. So I'm not sure that's one we really want to hang our hat on. Regardless, I feel like it meets most of those criteria, and so we would call it an old growth forest. But I would recommend in urban forestry that we just use a simpler definition, and that being a forest that's older than the city that surrounds it. The forest was here first, and Memphis built up around it. And to me, that's the definition of an urban old growth forest. So for the purposes of my research, it's kind of important to put urban forests into 3 broad categories. Now, it's somewhat artificial and there's gradations between them, but for this research, we're calling urban forests that are on public lands one of 3 types. The first being a street tree population. So you see the street trees on the left, and we all know what street trees are, but together they make up, the population makes up a forest. They're heavily managed. And then park tree forest. So the picture on the right showing sort of a mowed grass designed for aesthetics and beauty and recreation and benches and picnic tables. But the third category would be urban woodlands, is what we call them. So they're more natural areas. And the key features are they're not mowed, and they're more for habitat than they are for recreation, although trails are very common. So I purposely picked 3 sites that weren't in Tennessee, so we couldn't sort of jump on something we like or don't like about any of them. So we're calling these urban woodlands, but you might also see them referred to as urban forested natural areas. And there's a whole field of research around them. That's what we're talking about today. Okay, so that's the site, a very brief introduction to the Old Forest State Natural Area. And now I want to get into the research itself. So this slide, don't try to read these, but this slide is just to emphasize a couple of things. These are some of the research projects that have been undertaken in the Old Forest State Natural Area over the years. And when I started and we decided we wanted to do some research, the first thing we had the undergraduate students do is get in the literature, right? Find out what's been done already on our site. And those first 3 boxes are the only 3 studies we could find, going back to 1987. The rest of those are since the Overton Park Conservancy took over management. I just wanted to emphasize that we have prioritized research. And now those aren't our studies. Most of them are not. We've just been promoting them out to other institutions. Some of these have led to publications, some have not. Some of them are in the fields of anthropology and social sciences, but it's all been centered on the Old Forest. So it's interesting. We're going to talk about just one of those today. So in 1987, we found this, or in 2015, we found a 1987 article by Dr. James Golden, who was a forestry professor at the University of Arkansas at the time. He is now a research forester with the U.S. Forest Service Southern Research Station. And it was all about stand dynamics in the old forest, and we were fascinated by it and decided we could replicate that. So we went out in the field, threw together a team of undergraduate students, and we failed. We were unable to replicate the study. We weren't able to finish. And so we went back. You know, you learn a lot from failure. So we went back and we regrouped, and we realized we needed to build a team to get this done. And so this slide is supposed to show you the partnerships we built in order to get this study replicated. So the Conservancy reached out to nonprofits like Park Friends. They helped us fund some of the equipment we needed. We reached out to academia. We partnered with Christian Brothers and Rhodes College for undergraduate field techs. Mississippi State provided some funding and me as the principal investigator. And then TDEC gave us our permits, and the U.S. Forest Service was kind enough to send Dr. Golden to us to train us in the methodology to replicate his previous work. So without all of that, there's no possible way we could have got it done. And I think it just emphasizes how important partnerships are, especially in urban forestry. Okay, so our study is on what we call recruitment dynamics, specific inside the field of stand dynamics. And so don't worry too much about the diagram there. We like to show things like that, but it's a way to conceptualize where our research fits. I hope that makes sense. So in the outside of that circle are different points in a tree's life cycle where recruitment could fail. And by recruitment, I should say, we just simply mean the process by which new plants are added to a population. So they can germinate in and survive and grow. How does that happen? And so there are points along the way where it could get disrupted. It could get enhanced or limited, either one. We could have a point, so we think of this in 2 ways, where does the seed arrive? Does a viable seed arrive? And if not, why not? There could be things like we don't have enough adults producing seed, or we don't have dispersers. So maybe you want to disperse something that needs a frugivore, It needs a raccoon to eat a persimmon and then haul it away and deposit it. Well, urban forests could have that disrupted by maybe, say, a road, or an animal that doesn't want to cross that road you may lack dispersal at that point. I mean, I think a raccoon would get across an interstate if it wanted to, but it could be a barrier to dispersal, which would be a seed limitation. But once maybe a seed arrives, that doesn't necessarily mean it's going to germinate and grow. And what could be a barrier at that point? Well, it could be a lot of things, of course. Maybe there's a very deep leaf litter layer that wouldn't have been there historically. Maybe historically the site would have burned regularly and that leaf litter would have been consumed. And so a small seeded species now can't get to the soil, and it doesn't have enough energy reserve to run a really long radical down to the soil. That's a possible barrier to germination in an urban forest. Or, invasive species, of course, could be blocking sunlight, those kinds of things. Maybe there's an abundance of seed predators that didn't used to be there. Maybe you're actually just losing your seeds to predators. So there's a lot of places where the recruitment cycle could get disrupted. And then inside that red circle are just all the urban drivers we think of that could have an impact. So climate, so urban heat island, biotic invasions like invasives, and all those kinds of things. All right, so that's our framework and where we fit in recruitment dynamics. For our particular first chapter, our first study, we just wanted to replicate Dr. Golden's data. This is just observational data, right? We're not testing an experiment at this point or testing a mechanism, but this is how it laid out. We replicated a grid, but we didn't know exactly where his plots were. So we just replicated the size of the grid in a systematic way over the boundary. And then we installed these nested plots, and y'all can see the diagram of the different size circles. It's somewhat complicated, but the idea is simple. The larger circles are for the larger trees, and the smaller circles are for smaller trees. So there are fewer large trees typically on a per acre basis than there are small trees. And so if you try to just put one plot size down, you either end up missing all the large trees or a bunch of the large trees, or you count small trees for days and you waste your time. So this complicated design is part of why we didn't finish the first summer. And so Allie's over there on the right with some of the equipment we used. And it doesn't look like it, but that's several $1,000s worth of equipment that we just needed help purchasing, which is why Park Friends and those nonprofits were a huge help. So the orange top mechanism is a Hagloff DME cruiser. And what it does is it emits an ultrasonic pulse, and then a person stands with a receiver. And rather than trying to pull tape through that thick vegetation and get to 52 feet to know where your plot boundary is, you click the button and it tells you how far you are, because the sound will travel through the vegetation. That little thing cost $850, but it was a lifesaver. And then there's a small GPS unit, a Bad Elf GPS unit, that was connected to Allie's tablet, which we needed to buy, running ArcGIS field software, which allowed us to record everything electronically and then just upload it at the end of each day. So anyway, it's important to have some partnerships to help you get all those cool toys. Because at the end of the day, it really is about the cool toys and how cool you look doing the field work, if you want to recruit undergraduate students. All right, so what did we find? Let's start talking about some of the things we were looking at. And I haven't talked about our research questions, but we'll just kind of pull those in as we go. We really wanted to look at species composition because in urban forests, especially urban woodlands, we know they're pretty vulnerable to invasive species. They're very close to the built environment. We know that in the landscape, we use a lot of introduced species, and they can seed in pretty easily. They can make their way. So this was a little table we built just to show what we call departures and arrivals. We were hoping it would look sort of like the airport, departures and arrivals board. So I'm going to key in on the top part first. So just looking at the arrivals, so this would mean it wasn't here in 1987, or at least not in enough abundance that it would show up on the survey, but it was here in 2019. And then on the far right column, we just wanted to note, is it a native or non-native? And you can pretty clearly see that most of those were non-native. So that makes sense. We expected to see an increase in non-native species. We did see some American holly show up. That was interesting. And then pecan just kind of creeped in on the edges. So I wouldn't call that anything too significant. And now you'll see a star by cherry laurel. We're calling that in the non-native category because it's typically, from our understanding, native to the deep south, coastal Carolina area. And it's been noted to have not even occurred outside of that area up until the mid 1800s. And we think it has some issues, which I'll share with you later. And then if you look down at the departures, where what was here but is no longer here, they're all native. So we're not seeing hawthorn anymore. Osage orange probably was in pretty low quantities. And then the one that's really troubling is black oak. I mean, a native oak species that's no longer present in the old forest. It's a little bit dramatic, but we think we saw the last one fall about 5 years ago. Okay, so that's a brief look at species composition as it relates to invasive species, or at least non-native. But we also wanted to look at species richness and diversity, another way of kind of evaluating composition. So species richness is simply the number of species at your site. And as you can imagine, based on that table I just showed, we'll see more species probably now. So we broke that down to native and introduced. So our species richness technically went up, right, from 44 species in 1987 to 52 species in 2019. But then when you subtract the introduced species, they're almost even. It really stayed about the same from 44 to 45. Very little change in our species richness. Now, we like to use biodiversity as another indicator of composition because it incorporates not just species richness, but how evenly they're distributed in the landscape. So if you had two sites that were identical size and each had 5 species in them, and one site had 20% for each 5 species, and the other site maybe 90% for one species, and then the others were just trickling in at low numbers, the more even site would be considered more diverse. So what we were expecting, though, was what we've seen in the literature, at least, is a reduction in biodiversity as invasive species move in. So they start to dominate. So other species end up playing a much smaller role, and your actual diversity can go down. And that's what we saw. So our biodiversity actually dropped either way you look at it for all species. These are just trees, by the way. For all species or just the natives, it still dropped. Now, it's just trees, not shrubs, vines, and forbs, but I think we'd see something similar. And you can kind of look at it in that picture. You can see sort of almost a monoculture of a single species. So that's not necessarily that diverse. It's pretty with the celandine poppies, but it's somewhat monoculture. Okay, now we want to move into looking at species composition. And so we started by by looking at forest structure. And we started that by just digging into the raw abundance data. And so this is what you're looking at on the left. The red block is trees per acre in 1987, and the gray block is what we found in 2019. And if you can't read the numbers, we had almost exactly 1,000 more trees per acre in 2019. Now you have to be careful because that could just mean we had a good seed year. Like maybe we had a big acorn crop that year. So we ran another survey around that the next year, and just a seedling survey, and found that it was a normal year in 2019. So then we started opening the data up to see if we could find out where were those 1,000 more trees. And what you're seeing on the x-axis here is a size class, a size grouping. So seedlings, saplings, and you'll see this last two terms change a little bit depending on whose method we were replicating. Poles, which is really the mid-story, and then mature trees. So what you're seeing, though, is almost all of those 1,000 new trees are located in the sapling category. And so that's trees that are 1, 2, or 3 inches in diameter. And then we decided to open up that sapling category even more by a species component. And these are just groups. So, red oaks, white oaks, tulip poplar. It's kind of hard to read that y-axis. Ashes and elms, hickories and maples, and then what we call minor overstory species, so things that didn't show up quite as much, like sweet gum, and then understory species. And if you can see that, again, the dark red is the 1987 data and the gray is the 2019 data. So if you can read that clearly, the majority of our new trees in the sapling size class are understory species. Almost all of them. Yeah, there certainly was some increase in ashes, elms, and maples, but the biggest jump by far was understory species. And so, you know what I'm going to do next? We're going to open it a little deeper. We just keep opening up the layers. So we pulled out some of those understory species and looked for, were there one or two or three or four players that made up the bulk, or was it uniform across the group? And we found that two species made up the bulk of that jump, and that's pawpaw and cherry laurel. Now, y'all know what pawpaw is. The cherry laurel is an evergreen small tree, and it occupies somewhat of the same space as pawpaw, but the evergreen is interesting. So we started thinking that we might be developing what's called in the research a recalcitrant understory. So a dense, thick, and stubborn layer at the understory level, and that can have a dramatic impact on your regeneration. All right, so finally, we wanted to look at the large tree characters. So remember that these big trees are one of the key characteristics of the site, and so we really wanted to know how they were doing. But also, Dr. Golden identified this as a problem in 1987. And so the chart you're seeing is showing the red line are the oaks, and on the x-axis is size class. And on the y-axis is something we call importance value. So don't worry too much about it, but it's a combination of their density and their size, their dominance. But oaks were the dominant species in the overstory until you get up in the very large size classes, and that's when tulip poplar takes over on that blue line. And so this is what we're talking about. These are the trees these are the tulip poplars that dominate in that very large size class. Up to 6 feet in diameter. That tree itself, that's Dr. Grado, my major professor. That tree's 165 feet tall. So what Dr. Golden saw in 1987 that caused him concern was the red line on this chart. And so this is size class on the x-axis. And again, the terms change just slightly: seedling, sapling, mid-story, overstory. We thought people might just relate better to mid-story and overstory. And then on the y-axis is trees per acre, so the raw abundance. And you can see there were around, and then there's a table of the data. There are around 230 seedlings. This is a red oak group. This is just all the red oaks lumped together. I could show you similar data for the other overstory species, but there's about 230 seedlings per acre, and then you see a dramatic drop to less than 1 sapling per acre. So there's some sort of a choke point there, right? They're clearly not recruiting into the sapling size class. So we wanted to, and then you can see it goes up to about 10 trees per acre in the overstory. So we wanted to see how our data overlaid on that. And so I don't know where I get these colors, but I guess this Kelly green sort of color is from 2019. And you can see really the situation is not improving a lot for the red oaks. There are quite a bit fewer seedlings per acre. More of them are surviving to become saplings, but it's still not a big number. And we're definitely losing our overstory over time as they just mature out and die of old age. So we were thinking this probably is something called an oak bottleneck, where you just have a choke point, as illustrated by this graph of a Forest Service research data in Ohio. And what it's showing on the x-axis is size class, and on the y-axis a percentage of that size class. And it's showing how oaks are dominant in the upper size classes over there on the right, and they're somewhat abundant in the left. Now, you don't have to have a reverse J-shaped curve here, because remember, once they get into that upper size class, they live for a long time if the conditions are good. So they can stay there. You just have to keep replacing them slowly over time. But that pressure from maples in the middle is what was causing the bottleneck. And so we created our own charts using the same color scheme. I didn't label them, just kept with the color scheme. And you can see we don't really have that same pattern. Ours is being squashed on all sides. I mean, we don't even have the seedlings we would want. So our chart on the lower left is from 1987 and on the lower right is from 2019. So we kind of ruled out sort of that oak bottleneck. We're just having an oak choke. We don't know why, but something is preventing us from having almost any oak regeneration. But we definitely have a similar pattern on the right side, which is oaks and tulip poplars dominating, but certainly not dominating in the smaller size classes. We have a whole lot of other, and I would assume, we haven't broken this out, I would assume that blue, that other, is probably those understory species. We'll see when we really tease out the data. All right, so that's kind of a real short look at the research we've been doing on stand dynamics. I think the takeaways are these: species richness is going up, but species diversity is going down. So keep in mind the non-native species component of your urban forest. We're having species composition shifts, and we're definitely seeing a change in the large tree character. We probably have a recalcitrant understory as a potential barrier to those overstory trees regenerating. But what we really need to do now is experimental studies, where we go in and we test things. We remove certain things and we add things, and we find out what is actually causing that regeneration barrier. And so that's what we'll do next. We don't have data for that now, but we're designing the experiment, and hopefully we'll get started this summer. We hoped to start last summer, but we hope to do a lot of things last summer that we didn't get to do. Okay, so now we'll switch into some of our management activities. And we'll talk about invasive species primarily, and some use of chemicals. And I think we can get a pesticide CEU out of this, I think. So we think of our management, now I'm kind of switching hats to the Overton Park Conservancy at this point. We think of our management strategy as falling into three categories. So we have to manage for recreation, right? And we do that in the Old Forest with trails and signage and, scout projects and things like that. And then you heard about the research, but we also focus on forest health. And so that's what we're going to talk about now with our work on invasives. And this picture is of a AmeriCorps team working on invasive species. And, when the news comes out, we don't stand up in front of the camera. We put the volunteers in front of the camera and say, because that seems to be more compelling to the community. So that guy, poor guy on camera, was explaining why invasive species are important to manage. That seems to deliver a pretty good message, rather than us standing up there and preaching like experts. So this is just a short list of some of our woody invasives. We've got a lot. Most of us do. I don't know anyone out there that says, I don't really have that much in terms of invasives to manage. So what do you do when you have this many, and these are just the woody ones, it looks like, except monkey grass, I accidentally put that in. Well, first, you have to, as the TDEC stewardship ecologist told me once, you have to resist the urge to curl up in a ball and quit. You feel like you're never going to get anywhere. So instead, just take a deep breath, take a step back, and develop a strategy. And so that's what I want to talk to you all about, is the strategy we started with when I first saw this list and felt like I was never going to make a difference. So first of all, we had to make management decisions. And the first thing we had to decide was, are we going to inventory and map these species and try to get a handle on what we have and where it is? Or are we just going to jump in and start swinging machetes and spraying chemicals? So, and I'm making that a little more overly dramatic. We wouldn't just go crazy. We decided we would do a little bit of both, but we definitely wanted to do some inventory. And the reason is because we're privately funded, and we need to go to our funders and keep asking for money. And it helps if you can show progress. If you can say, we had 1,000 Tree of Heaven, and now we have 400 Tree of Heaven, we're making progress, please keep funding us. Your money's going to a good cause. It's helpful. It is, however, hard because it slows you down in the beginning, and it's very risky if you have kudzu or wisteria or something that spreads very quickly. You can't take a couple of years and just let it run. So you have to sort of have a plan for attacking those at the same time you're doing your inventory and mapping. You also have to decide the scale of what you're going to do. And so is it intensive or extensive? And by Extensive, I mean just focusing on one species when covering the entire forest, just going from border to border, getting that one species. And by intensive, I mean picking a spot and working on every invasive species in that spot. And so we had to adopt a strategy of a little bit of both, right? So for kudzu, we practiced extensive, right? We had to get it everywhere. You can't leave it. And then more recently, we started working on a model of intensive management where, like this kind of blurry picture is where we had a scout who just spent a day with all of his team working on a small area. And then we put up signage that says we removed all of the invasives from this area and we're going to keep up with it. And then we're slowly going to add to that area and expand out and expand out. So there's pros and cons. And I recommend you try a little of both. And then not finally, but you have to decide also on the mechanisms. We are big fans of using chemicals. I think you have to, if you want to make a reasonable progress on invasives, you have to be able to embrace use of chemicals. You do it carefully and you follow guidelines, but you have to. Now, we also rely a lot on mechanical work. And those are uprooters in the picture. I recommend you use them for things that can be uprooted well, like privets, smaller size privet. We use it on cherry laurel too. But don't be afraid to come in also with that backpack sprayer. And then there's just try other things. That red tube is called a weed wand. And we don't like it, but we used it for a while and we tried it and we developed our own version of it afterwards. But try different things. And then who are you going to use, right? Who's your workforce? How much can you do with volunteers? Can you put chemicals in the hands of volunteers? So that's a tough one. But, you've seen the picture there, Bill Bullock. Everyone in West Tennessee knows Bill Bullock. If you can get a volunteer like that, he can help lead volunteer efforts. Bill started studying. He became a certified pesticide applicator. He studied that book, that Dr. Miller's book. And then he just follows the guidelines in that, and he pulls together teams. Now, you can also use private contractors, but we found that it takes a bit of training. And by the way, if you want that book, just there's the link to it. It's free download from the Forest Service. But don't be shy about using volunteers, and they can get a lot done. Just remember that they'll probably be mostly doing mechanical work. And you'll have to come in with chemicals after everything starts resprouting in the areas they've worked. But it's okay. It's still very helpful. And you build all that community support as you go. Okay, so I'm going to show you just real quick. We're getting close to the end, but what we did with two particular species, starting with kudzu. And so when I started, it was pretty bad. And even though we wanted to really get going on it immediately, we took a minute, in fact, an entire season, and we just started mapping it. We were looking because it was up in the canopy and hard to find. So we just started hunting and mapping. And when it says we used cultural clues, we had this anthropology student that had read newspaper articles about where kudzu, in his history research, about where kudzu had occurred in the forest, and especially in the box elder patches. So that really helped us find it much more efficiently. It was real cool. And then we jumped in first with mechanical work. So like the picture on the right, we would hack at that overstory. We couldn't get chemicals up in that tall overstory, and we wanted to get it down to what you see on the left side picture, which was where are the roots going in the ground, and what are we looking at for stems. And then we practiced what we called surgical excavation, which is me and Bill just digging and digging and digging and tracing the roots until we came up to it's really time consumptive, till we came to like a big bulb. And then we wouldn't cut all the laterals. We would actually excavate around the bulb, and we would apply directly to a cut surface, Tordon, ready to use version, non-diluted. And I recommend you get sort of a foam applicator on the end of the bottle, or drip it directly, but you can get a little overspray if you drip it directly, or you can get a little of it on the ground, and you can get some non-target kill that way. But we would use this quite a bit, and we knocked our control efforts. When we started, we were putting well over 500 staff hours a year on kudzu, and we're down now to about 30 staff hours a year, and we rarely find. That's mostly us just looking for it, trying to find it. I mean, it's still there, don't get me wrong, but it's just a really effective use of that chemical and that mechanism. Now, when it's foliar, of course, I recommend transline. Transline is expensive, but we ran some experiments with transline where we would just drape it through the spice bush, the kudzu, drape this kudzu through the spice bush and soak them both with transline. And we never lost a spice bush, and it always killed the kudzu. So moving on to Tree of Heaven, this is a nasty player. And we took our time mapping it. We went ahead and we focused on disturbed areas. And you can see this 1901 map of the park where we had identified old roads and trails on there. And that's where we found Tree of Heaven, just almost in straight lines. I mean, it looks like it was planted as a street tree in there, especially along the old roads. And then we did do some mechanical work, but I don't recommend much on Tree of Heaven. And it says that in all of the guides, don't try mechanical control. But of course we had to. We just wanted to see what would happen. And we girdled a couple of medium-sized trees. And for every tree we girdled, there were a minimum of 300 root sprouts for each one that we had to deal with very soon afterwards. And they very quickly grew out of our ability to apply foliar chemicals. So you come back in a couple of months and they're 12 feet tall and you're looking at doing another mechanical cut. But that's okay. You can keep stressing the root system that way, forcing it to resprout and forcing it to resprout and draining that root reserve. But we mostly relied then after that experience on chemicals. And so I would recommend on the larger trees using a hack and squirt method. And so a little machete there. And I recommend finding a bottle that can be labeled, number one. So you really want to have everything labeled. Anybody that walks up to us in the forest, we'll show them what we're using. We try to keep a specimen label in our pocket and hand it to them so you can relax about what we're using. But that can be doled out in a measured amount, so you can assure yourself 1 milliliter of spray for each pull of the trigger. And you know what a hack and squirt is probably. You just you chop into the bark just a little bit. You don't want to go very deep. You're just trying to get into the vascular system, and you fill that cut with the chemical. And you don't girdle the tree. You want to leave spacing between your cuts so that the system still moves. And then you got to be patient and let the chemical move through. And we used for that, we would use a Garlon 4 product or an Element 4 product, anything like that that was triclopyr and the ester formulation mixed in with basil bark oil. And then on you see that weed one we said we didn't like, we developed our own version of a basil bark treatment, which is for trees 1 to 6 inches in diameter. And that's a long-handled 4-inch foam roller. You just go to Home Depot or someplace or Lowe's, make sure you get a really long one, a 26-inch reach or something, and use a 4-inch foam roller. And then we'd take that squirt bottle and soak the foam and then just paint the trunk rather than try to spray it from a 3-gallon backpack sprayer and get it all draining onto the ground. We always thought it was funny. No one ever asked us what we were doing walking around with paint rollers in the forest, but I don't know. And then this, guess is kind of what it looks like. A couple of little hack marks and some squirt on a Tree of Heaven. That tree's dead. Unfortunately, it was a tree that had the T-deck boundary sign, but anyway, that's hack and squirt on Tree of Heaven. Okay, I know I kind of went fast, but I believe that's the bulk of what I wanted to talk about. And to summarize, I guess we talked about the site itself in the old forest, some of the key characteristics like the big vines and the flowers and the old trees, and then a little bit of the research, especially on recruitment dynamics, what might be causing some of those recruitment failures. And then just a bit about how we manage invasives and how to use chemicals in an urban environment, and be very careful, follow the guidelines, and don't hide anything, share it with people. Keep a copy of your specimen label in your pocket, and anyone who wants to see it, let them see it. But at every step, I think it's critical that you build some partners, get the community involved, and because they may like what you're doing, but if they're not involved, they may not trust what you're doing, and you need them. You absolutely need them. So special thanks to Dr. Golden for coming all the way over several times for the price of a lunch, and then of course my committee, and then all of these other people we've been working with. But really appreciate you all for putting these together. Joellen, thanks for getting me here and making sure I came and showed up. And Dr. Jean-Philippe and Neil, I really like the way you guys are putting these together. And Christy, thank you much for helping me out. So that's it. I'll go ahead and get out of this, and we can take questions, I hope.
Yes, if anyone has a question, since we're a small group, you can feel free to unmute yourself and ask a question, or you can put it in the chat box and we'll ask it for you. And while we're waiting for questions to come in, I just want to remind everyone about getting credit. So if for whatever reason you didn't fill your account numbers out on the registration form and you need credit, just shoot me an email at that address and we will take care of it. Okay. Okay, we have one question from Neil Letson. Many communities have urban woodlands, but not the means to replicate your survey. How would you recommend they complete a less intensive assessment?
Okay, yeah, that's thanks, Neil. So I would approach it a couple of ways. I would try a couple of ways, and I'd start by reaching out to the Forest Service and see if they have any what we call FIA data, so Forest Inventory and Analysis. So that's a program that they have now do in urban areas as well, and now it's a broad level, so it would be it's not very likely to have multiple plots on your urban woodland, but that's a start. You could get a sense of the makeup of some of those urban woodlands near you, and then you certainly don't have to replicate that intensity like we did. I would caution you also that this is not suitable for iTree. So like one of the reasons we messed up the first year was we were trying to gather a little extra data on those canopy measurements so that we could put it into iTree and calculate a lot of these values, right? That's a whole different animal, and you have to decide if you want to do one or the other. But anyway, I think you could easily gather, not easily, I think you could, with a lot of work, gather a community team, right? Like your Urban Forestry Council team, volunteers, and design with the help of some academics. I think we'd all be happy to help a much lighter inventory. And so you would be doing, I would switch from a fixed radius plot to a variable radius plot, and I can explain all that at some point if we want to get into the details, but it goes a lot faster. You'll just lose a little bit of accuracy, and that you don't need to be as detailed as we were. Anyway, there's ways to sort of skin that one. And I'm getting a little rambling, I'm sorry, but yeah, I think you could do it with volunteers, a little bit of training, and I think it'd be a lot of fun, actually.
Thank you. We have another question. Are you going to treat for emerald ash borer to save the ash trees in the old forest?
Yeah, that's a very good question. And we've wrestled with it and we've landed on both sides. It seems like it depends on the day we're talking about it. But where we are now is we're going to treat key spots. So we have some 5-foot diameter ash trees that we just don't want to lose. They're right on the trails and they have little trail markers on them, and those are going to get treated. And any other place where we have really nice key spots that we want to save that seed source. And then in the rest of the forest, we're going to have to probably take a less hands-on approach, and unfortunately.
Okay, thank you. And can you give us a website for the book that you mentioned?
So let me see real quick. I think I can. But if you Google Management Guide for Invasive Plants, it'll come up. But the website, I'll type it in the chat. I'll get it typed in here.
Great, perfect.
I have a question. Can you hear me, Christy?
Yes, we can hear you.
Oh, okay, I didn't know. Okay, the recalcitrant understory, does that seem to be primarily because of the invasive species? You don't feel like there's much of a deep leaf litter or layer, that sort of thing? So,
yeah, I think invasives are playing a big role, but I think it's also some of it is also simply some of the recalcitrant understory is pawpaw, right? A native pawpaw,
right?
And I think the reason we're seeing that is we've got a disrupted disturbance regime, right? So the typical factors that would keep pawpaw maybe at a lower level. You know how you have to hunt for pawpaw in many forests.
Yeah.
I think we've just not seen those disturbances like fire and flood. So, Judy, think about like the Lick Creek used to flood, regularly in that area. And now it's in a concrete channel, right, since 1937. So so that's it's not all just fire, but there's other factors like that that are allowing even natives, but I do think non-natives are a big part of why we have that recalcitrant understory. And I'm not saying we're going to put fire back on the landscape in that area. I'm just saying we'll have to acknowledge that some of those disturbances are not there anymore. And if we want to get certain species to regenerate, we may have to be a little more active than just saying we're going to allow passive regeneration.
So the approach to getting the oaks, are you by getting rid of these, these saplings that reproduce at a real high rate and grow much faster than the oaks, by getting rid of things like the tree of heaven, are you going to do that like in an intensive area somewhere to see if you see a change in the what the oaks and the poplars do in that?
Yeah, that's right, Judith. So what we'll do is we'll have experimental plots. They'll be real small, usually about 1 meter square, but we'll have a lot of them. And in those plots, we'll have, we'll manipulate different things. We'll remove some of the competing understory layers. We'll manipulate the leaf layer. We'll simulate a fire, basically by kind of raking through the leaf layer. You got to be careful because that's also simulating grazing because you're stirring up the soil. But things like that, and then we'll test germination rates in those different treatments. So that's the approach. And some of that will be removing, invasives only, invasives plus natives, anything competing. So we're really going to look at 3 factors: above ground competition, leaf litter layers, and seed predation. Those are the 3 key factors we think might be we think. And you can't do much more than that or you'll just be there for years. But we're going to try that for 2 growing seasons and see what we get. And we're also testing cherry laurel. I mentioned it earlier, then I forgot to follow up, for potential allelopathy. We've got actually some lab work going right now. We've got cherry laurel seeds ground up and soaking, making we call it our tea, but I wouldn't drink it. And we're seeing what cherry laurel's effects are on regeneration as well.
They put toxins into the soil, the cherry laurel. I didn't know about that. Yeah.
Well, potentially they do. That's what we're trying to determine, is if they are allelopathic or not. They're known, other species, of course, in that genus are known to be allelopathic, and cherry laurel is known to produce cyanide, but we don't know if it's affecting germination or not.
Are you, Eric, are you going to put black oak back in the forest?
Yeah,
I know a tree where you can get some.
Yeah, I will open that up to anyone who has a high producing oak. Please let me know. We will gather those acorns and we will use them for our experiments. Yeah, we do want black oak back, and we want to maximize diversity. So if we can get them from a variety of places, it's actually a really good thing.
The Arboretum at Drummond's Park has got a huge one.
I didn't know that. I'm writing that down.
Yeah, you can go there anytime. It's open.
Yeah, just watch out for graduate students. They're ridiculous. They'll take everything.
Go ahead.
Okay, the link to that PDF is in the chat for anyone who wants it. And we have just a couple of minutes left before we have to let Eric go. Does anyone have any final questions?
Eric, was most of your attack on the tree of heaven, was that done during the summer, since it's since you were controlling it with chemicals?
Yeah, that's I think that was Dallas. Yeah, that's a good question. So the timing of those chemical applications is pretty important. And so really later in the growing season is when you want to work on those vascular ones. At least that's what we found. A spring treatment does not seem effective for a hack and squirt or a basal bark. And weirdly, late winter does. So if you can get it before leaf out sometimes, I don't know what it is. Maybe it's just, we get some of those warmer days before leaf out or something, but a late winter application can actually be kind of effective. But for us, the ideal was in that September, October range. I think most of our applications were in September, if I had to guess.
Okay.
Okay, Neil, would you like to wrap us up?
He's on mute, it looks
Let
like.
me, I think I'm unmuted now, but thank you, Christy. And thank you, Eric, for a very informative, practical presentation on I would say, an overlooked component of our urban forest, and that's the urban woodland. So I've learned a lot. I know everybody else has as well, but thank you again for giving a great presentation. And I think just in closing, Christy and Joellen and Sharon, our next speaker is going to be Dr. Paul Reese. Next month, I don't have the date, but that should be information on the website. And he's going to talk to us about rethinking trees. So everything you know about trees, I would be prepared to expand that and look at them a little bit differently, but this should be a great presentation. And then lastly, this series of webinars, we've made a decision to continue these on a monthly basis. And we really would like to hear from you on topics that would be of interest and meaningful to you. So please share those with us if you have an idea for a good topic that would help those of us in Tennessee to better manage our urban forests. We want to hear from you. So with that, once again, I want to thank Eric for a great presentation, and Joellen for lining him up for us, and for everyone for attending today's session. So thank you very much.